Hello. Today I'm going to be solving some problems from Codeforces Round 646. I was unable to participate in it live, but I did look at the problems beforehand just to look at the length of the problem statements during the contest. And so I decided to, instead of virtualing, just go over the problems separately. This way, since I already read a few of the problems, um, it wouldn't really be much of a virtual. Also, I can explain more. So yeah, I'm gonna start with problem A. Um, there, something's odd. So yeah, it looks like a pretty easy problem. We just have to make the sum odd, and the only way we can make the sum odd is having an odd number of odd numbers, because even numbers don't change the parity, and so we have to try to make an odd number of odds, and so there's only two cases for that, or there's four cases for that, really, I think. So we have multiple test cases, and we have to scan in our n and x, and we'll keep track of how many evens and odds there are. 0. So if a is even, that means a mod 2 equals 0, then e plus plus, else odd plus plus. So if the number of odds is already odd, so if O mod 2 is equal to 1, then we know we can just add all the other even numbers and we can make the requirement for x. So we can just print out yes for this case. Otherwise, if odd is even, then that means we have to remove one of the odds to have an odd number of odds, and so the rest have to be even. So that means we'll have one less than the total number. So the only case it won't be, it will be a no, is if x is equal to n. Out.println no, else out. Yes, because if x is equal to n and we remove one of the odds, then we only have n minus 1 elements to work with, which is not enough to fulfill the requirements for x. And let's test this. So it looks like it passes samples. Let's go ahead and submit this. I think this should work. I got a wrong answer, test 3. What did I do wrong? Actually, I won't look at the verdict yet to figure out exactly where I went wrong. So if there's an odd number of x, then we should be fine, because let's say we had 3 1s or something, it would just be, yeah, it would just be odd. So I think this case is correct. I'm not entirely sure why this case. Is it because, there's also that one case if there's no odds at all. Yeah. Or Yeah, this was just a silly mistake. Probably in contest, I would probably check it a little bit more to make sure. But yeah, I think that's just an easy fix right there. Oh no, it's still wrong answer in test 3 for some reason. Why is it wrong? So in this case should be fine. Otherwise, if x is equal to n, we'll come back to this problem. I'm not entirely sure why I got wrong answer. Even though it looks pretty easy. So on to problem B. So in order to make it good, basically, well, if its length is less than 3, it should just be 0. I think let's see here, like in this case here. Oh, okay, so okay, okay, so it has to be all zeros or all ones, I'm assuming, or it just or it's just all zeros and all one on one side, or flip it and such. So yeah, shouldn't be too difficult. Okay. So you just count the number of zeros on one side and the number of ones on this side. So we can first we have to scan in all the input. Char s equals char array, and then so let's set our default answer to the number of zeros there are. So and I char c and s if c is equal to 0, because we can assume that we just make them all ones in the beginning, and then we just loop through and try to make this many zeros and this many ones. So if I equals 0, I is less than, and dot length, or that's not name, plus Actually, we'll keep track of the number of ones and zeros. And yeah, should be it. So if we're assuming that we make all the actually we don't even need this. So we make all the left equal to 0 and all the right equal to 1, or all the left equal to 1 and all the right equal to 0. So yeah, we can just keep track of how many ones and zeros we want. And yeah. Yeah, I'm not sure. I just keep track of prefix sums. I know there's probably a easier solution for this, but yeah. 0 equals new int new int s dot length for line s dot length I plus plus. If I is equal to 0, I plus plus, else O of I plus plus 0 plus, what is happening? O of I minus 1, and then yeah, that's like a real range function. Return is equal to 0, r minus l minus 1. Okay, so so we can loop through and equals max value. So we can loop through all the positions where we switch. So yeah. Equal to map.min sum from 0 to I z yeah plus let's see. Plus 1 2 oops I plus 1 to stop length, or we can just even do if L and R return 0 plus sum of I plus 1 to stop length minus 1 O and we can just flip it here. I think that should be it. Yeah, let's see. Yeah, it looks like it's working. Now let's submit this. Okay, got accepted. Yeah, it took a little bit longer than expected, mainly because I didn't want to use prefix sums because I thought maybe that was like some type of overkill or something, but I ended up using it anyway. So yeah, the main intuition behind this problem is you can have all zeros on one side and all ones on the other side, or all ones on this side and all zeros on this side. So yeah. So on to problem C. After problem C, I'll go back to problem A. So problem C I actually looked at beforehand, and I actually thought about it, and it seems pretty simple to me. Basically, you just check if X is already a leaf, and if it's already a leaf, obviously the first player always wins. Otherwise, you have to, if it's not a leaf, then you have to remove n minus 2 nodes, because after you remove n minus 2 nodes, then and since the players will always be playing optimally, they will always remove n minus 2 nodes, because if they do it earlier than that, the other player can easily just take the node. So once you take out n minus 2 nodes, then node X automatically becomes a leaf and that player wins. So you just need to check for the how many connections for X there are, and if to check if it's a leaf. And if it's not a leaf, you can just check the parity of n to get your answer. So yeah, seems pretty straightforward. Scan it in. So n equals 0 plus oops, a is equal to x or b is equal to x, then we're adding another connection to it, plus. So there's this special kind of tricky case where there's only one node, and in that case the first player also wins, because it says a leaf node is with degree less than or equal to 1. So we can just check if the degree or count is less than or equal to 1, then the first player always wins. Otherwise, so if n is even, like then, so like in this case here, where we have a tree where and we root it at 1, and we have node 2 and 3 coming off of 1. So n minus 2 would be equal to 1. And so if it's odd, then the second player always wins, otherwise the first player always wins. So if n mod 2 is equal to 1, then Second player always wins. Otherwise, it's L and first player. I think this should be it. Yeah. Let's test it. Yeah, it looks correct to me. And you can go ahead and submit this. And let's see if it works. Yeah, it looks like it's working so far. Okay, yeah, I got accepted. So yeah, I think this problem's pretty cool because it's like a graph problem, but not really, because you don't have to do any graph algorithms, just know how graphs work, which is a good introductory introduction into graphs in general. So yeah, I'm gonna take a look at problem A again and see what's wrong with my solution. I could probably just do brute force solution, where I use brute force over the number of odds anyway. And then I'll look at why my previous solution was wrong as well. And, plus I can I plus equals 2 because yeah, should be fine, because yeah, we always need an odd number of odds to make an odd sum. So if n minus I is less than or equal to number of evens, then we can always print yes, turn, otherwise we print out no. I think this should be fine. So yeah, let me submit this. And we'll see if it gets accepted. Oh, okay, even faster. Wrong answer now. For some reason this problem's giving me a lot of trouble. I'm not entirely sure why. Oh wait, oops, this was the wrong condition. We have to take into account x. I didn't even use x in my if statement, which makes no sense at all. If e plus I, because we can just add as many evens as we want because it doesn't change the parity at all. So yeah. Okay, let's submit this now. And I finally think this should be correct. Okay, I keep getting wrong answer on test 3. Yeah, I'm just gonna go ahead and look at it because we can see how we can possibly debug this. So we're printing no when it could actually be yes. And I don't see how. So it's on the 5th test case apparently. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. So I think it's on this case here. Oops. Is that the fifth test case? It's 1, 2, 3, 4. So yeah, I'm printing out yes here when. Oh, I'm printing out yes when it should be no. Oh, okay. I didn't take into account the case where there's no evens, which is a big problem. I feel like I should be taking it here. Let's see. I can do 1 or 3. Okay, it should be exactly equal to x. Yeah. Yeah, I think really stupid, but because if it's greater than or equal to, then it just doesn't make, well, and I has to be less than or equal to x. Because if I is greater than, or, yeah, because if I have more odds than x, then it doesn't work. So we can test the case out again. Yeah, okay. So it looks like it should pass that now. Yeah. So, yeah, really silly mistake. 4 wrong answers on A. I would probably take more time to look at it in contest or something if I kept getting wrong answer. But yeah, I guess you just have to watch out for mistakes like that. I only took into account the case where there's only one odd, but I didn't even look at the case where there's no evens and such. Anyway, we can go to problem D now. So yeah, I saw this was a interactive problem, and I really don't like interactive problems in general. I actually didn't read this problem yet. I only read that that it's an interactive. So this will be my first time reading it. The block has k slots, where each slot can hold integers 1 to n. The password p is k integers 1 to k. So that k non-empty mutually disjoint subset. So yeah, equals max age. So it's the max out of the subset. Okay. Oh wait. So it's not in the subset. That's kind of strange. Okay, so you already given the subsets. So the query. Okay, wait, so I'm a little bit confused because so all the subsets are disjoint, meaning they have nothing in common. So what if there's only one subset? Because I see that K can be 1 as well, so I'm a little bit confused about that. Let's see. I don't know unless I'm reading it wrong or something, probably. It's a number of test cases. Okay. Wait. So yeah, okay. Okay, so it makes a subset of indices, yeah. Okay. Space separated integers. Okay, so yeah, I'm not entirely sure how to approach this problem just yet. Wait, so what do we even have to guess anyway? Okay, so you have to guess the password. So I'm still confused. What do we do when we only have one subset? Because it says the remaining ones. I wonder if there's clarification or something. Doesn't look like it. Yeah, I'm not entirely sure. At least, Yeah, this is kind of tough. Um, so I mean, yeah, I'm not entirely sure how to solve this problem yet. Maybe I'll come back to it. I'm gonna go ahead and look at problem E because I think that one had more cells. Yeah, almost double the amount of cells. Okay. Okay, so as the end nodes, the ith node has cost AI and the binary bi is written in it. The ith node in the end. Okay, so this is pretty interesting. Yes. Hmm. Um. So let's look at this example here. Um. Yeah. Okay. Yeah, this is a pretty tough problem. It looks like. Um. Yeah, I'm not entirely sure how to tackle this problem, but I'm gonna go back to problem D and maybe look at the editorial because yeah, I'm just not good at interactive problems in general. So yeah, maybe I can look at the editorial and come up with the actual code on my own. So let's head over there. If Codeforces loads, right here, and I think this will probably be the last problem I do. So the key idea is the maximum Oh, yeah, that makes a lot of sense. I didn't. Yeah, okay. So I'm gonna. So yeah, the observation is that for every position, the max will always stay the same, right? Except for one position that does contain the max. So for the one position that doesn't contain the max, um, we can go ahead and um, look at it, I guess. And if not, I'll go back to editorial and see if I can get any more insight into this problem. So, um, so we just have to get the first and second maxes, and we just have to know the relative positions of each other, so that yeah. So how do we get the first and second maxes? Um, well, I guess. So first we find the first max, and then we can exclude that, and then do the subsets again. We can clear the subsets again, but yeah, it doesn't even matter if. So yeah, we can probably do some sort of binary search or something. Like we can keep splitting the array in two, because if the array is of size 1000, log of 1000 divided by log of 2. So yeah, it's only like 10 tries, right? Well, it's not really binary search. I guess we just splitting the array in half every time. Um, yeah, and after we implement that, we know what the max is, and to find the second max, we just have to query everything else outside of the max. So let's implement this idea. This is the number of test cases. And the bad thing about interactives is that it's kind of hard to create your own test cases because it's constantly querying you. And unless you have like you program your own thing, you have to manually input it every time. So yeah. So we have to scan it n. So I still don't understand if k is equal to 1, what do we do? Because if there's only one subset, then how do we find the max? So I'm going to assume that k is greater than 1 for now, because I'm not entirely sure what we do. If k is greater than 1. Yeah, it looks like So I'm assuming if there, so not all numbers have to be included in the subsets apparently, which makes sense. Yeah, makes sense, I guess. So yeah. Okay. And then we scan in the actual subsets. And yeah, okay. Equals new int, int size, and then we scan in. So I guess we can keep splitting the array in half or something, and then, well, actually I just realized that doesn't work, because what if we check the left or some side of the array? Well, I guess it narrows it down anyway. Yeah, okay, never mind. I think this idea still works. So int was equal to left is equal to 0, right is equal to n minus 1. Or really, it should be, since it's one index, I guess, we can do this. So we know what the max is, and we just have to try and get the index of it. So we'll always try to query the right one, and then just based on that one query, or we can query the left one or whatever, and after we split it, and if it's based on that, we can decide if we want to go down left or right. Oh, max index, max val is 1. Okay, so we have to out.print question mark. And then, yeah. Print I is equal to 1 plus plus. We'll have dot print I if I does not equal. I don't know how spacing works, but I'm just going to make sure that it's accurate. Okay, and then print a new line. So after we query, we'll get our answer, or our max. Max val is equal to math.max, or max val equals scan extent. Oh, and we have to flush this as well. Flush. Okay, so now that we know what our max val is, we can start keep dividing by 2. So while left is not equal right, we can query all the way to the mid, and mid is equal to left divided by 2, and yeah. I suppose if it's like something odd, I don't think this matters too much, but maybe we want to query the, I guess, yeah, it doesn't matter anyway, so we still have to do our query. So the amount of query size is equal to mid minus left 1% t mid, and then our query size printf. for int I is equal to 1, or if I is equal to left, I is less than equal to mid, I plus plus. So if max, or we have to print, we have to still query print I, and then if I is not equal to mid, I'll print this. Oops. And yeah, okay, it's still the same thing. Yep, and then out.println and out.flush. Just gonna copy this. And int cur max is equal to scan max. And so if the cur max does equal to the max, it is possible that the right side could contain the max, but we know for sure that the left side does contain the max. So we can just go down the left side. So if cur max does equal max val, and we say right is equal to mid, otherwise. And I don't think they should infinite loop, because if we have like 2 for example, yeah, otherwise the left else left is equal to mid plus 1. And then yeah, that seems right to me, because we know that the left side does not contain the max at all, so we can just keep going down. And then the max index should just be equal to what's left, because now left and right we've narrowed it down all the way. And so now we know that everything so and then we can get the second max easily if we send n minus 1, because if so if I is equal to max index, then just continue, because we already know that we just want the second max, not dot flush, and then int second max is equal to scale max int. And that should just be it. Let's go and I is equal to, so for all the k subsets, then alright, did it say we have, oh no, yeah, I should have just scanned in k subsets, not all of them. Okay, then okay. Boolean contains max index. So let me explain this in one sec after I and j in sub I is equal to index. So the idea is that basically if we're not at a max index, then the max index value will be the passcode for everything else, except if we're at if a certain subject does contain a max index, then we can't use that because it's everything else. So yeah, so if it contains max index, alright, and we also have to start a query out.print, and then out.print second max. Otherwise, we can just print out the max. And yeah, and then if it does not minus 1, out.print. I think that should be it. Oops. And string result. If result is equal to incorrect, or yeah, we don't really need to check it anyways. Like if you're doing it specifically for debugging, then you could use the result. Otherwise, I think it should be fine. Okay, so let's test this out. I'm using the sample here, 1, 2, 3, 4. The max is 4. Max of 1 to 3 is 3. Okay, it doesn't look like it's working. Or is it? Wait. How did you guess it? Wait. Oh, yeah, okay. Because they already found the max index and then query. So yeah, it looks like it's working. Correct. And it terminates. Let's submit this. Okay, wrong answer in test 2. I'm gonna go ahead and look at this. Mainly because this problem is really hard to debug. Okay, so the number of queries actually exceeded 12, even though it really shouldn't. So yeah, 1, 2, 1, 2, right? And then so we query 2, 1, 2. Okay. I'm saying in the case that it's 1, 2. Why is it querying? That is just not correct. First of all, why is it querying to 3 and 4? Let's see. Let's manually type it in. 2. Okay, so let's say we reverse it and the array is actually 2, 1. We'll still just say 2. Say query it again. 2. Okay, so yeah, it is infinite looping for some reason. Even though I'm pretty sure I made sure. Oh. Yeah, actually I'm not sure why. Oh, this is why. But, yeah, early student mistake. 2, or sorry, 1, 2, 2. Yeah, 2 subsets contain the index 2 each. 1, 1. Query 1, 2 is, and yeah, that's correct. So wait, why did it do that last query? I'm so confused. Alright, because Well, yeah, okay. That makes sense. Let's go ahead and submit this now. This should terminate after I say correct. I'm not testing it on test one because I'm pretty sure it works. Otherwise, if it doesn't, they'll tell me anyway. Copy and paste it. I didn't know. Problem. Okay, yeah, looks like it's working now. Okay, wrong answer on test 37. That's really interesting. Why would it get wrong answer? I saw some other people getting wrong answer on test 37 as well. We can go ahead and look at it. So it's saying the answer is actually more than it actually is, which is kind of strange. Wait, let's look at this again. Test 37. That's really interesting. Huh. Yeah, I'm not entirely sure why. It should be getting a wrong answer. Let's see. Yeah, I'm not entirely sure why it's getting a wrong answer. So let's say we have an array of all the same elements, or maybe one max. So let's say we had like 5, 5, 5, and 6. So 1, 4, 2, and then we have 2, 1, 2, and 2, 3, 4. So that's current, so we'll say 6. We'll say 5. It's 5. It's 5. That's not correct. It should be 5, 6. So let's see why that's happening. Oh wait, no, it is right. Yeah, okay. Oh, it's because if the second max is, duh. Okay, yeah, that makes a lot more sense. Because even if the second max is with the max, it doesn't make any sense. So yeah, I'm not sure how to account for that. So wait, so all the subsets are disjoint anyway. So that means there can only be one index with the max. Or unless I misread, because it looked like in test case 2, unless I, yeah. Two, 1 2 1 2 1 1. They're all disjoint anyway. Okay, yeah. I think so. First, we have to find the index with the max anyway. So -1 print I. Unless I read the problem wrong, there can only be one index with the max, right? So just be subset index equals I at break. Yeah, hold on. So let's get rid of this, and then we have in second max. So if subset index does not equal -1, and minus sub of subset index dot length. Yeah, we have to. We can just add it to a hash set, I guess, actually. Skip is equal to hash set for everything. So index skip dot add from that. So if skip dot contains skip dot contains I and continue, otherwise say second max, then I think this should work. Okay. So we can test it out actually. If we say have the array 2 2 4 5 or something, or yeah, or 1 2 3 4 actually. So 1 2 2 2 1 2 2 3 4. Okay. So did it break or something? Because I feel like that should be 1 4 2 2 1 2 4. X is 4. It's 2. And they'll say the max is 3. Okay, it looks like it broke or something. Not entirely sure why. It's because I need to flush it out or something. Okay, let's do that again. 1 4 2 2 1 2 1 2 3 4 4 2 3 2. Yeah, that's right. And let's say correct. So yeah, just silly mistake in rushing caused that to happen, because the second max, even if the second max is in the same subset as the max, we can't use it either. so we have to query everything outside that range. So let's see if this works now, and it should. Okay. Yeah, passed it, so it looks like that was a problem. Yeah. Okay. Yeah, accept. So overall, not a bad as problem as I thought. Like usually interactives are scary for me or something, but this one was not too bad. Just had to make sure not to make the silly mistake of um, including second max and max. And yeah, so I think I'll stop there mainly because I think it will take too much time for me to solve. Yeah, so overall this contest was not bad. Um, it seemed pretty easy for the most part, except I did make a lot of silly mistakes, like 4 wrong answers on A, mainly because of me rushing. And but yeah, overall it's pretty good. See you in the next video.